Hello students, welcome to Bretter. So in this video we will get to know what is binomial distribution, what are the conditions that are required to identify the distribution, and firstly we will see the real life examples of the state distribution, and then we will get to learn about the solved example, and lastly uh, we will get to know that how to solve binomial distribution problem in step-by-step manner with Bretter application. So let's start. Now, firstly, we will see that what is probability distribution of binomial function. So as we can see that in screen, the probability density function of binomial distribution is depicted. So what are the parameters? N is the number of independent trials, P is probability of success of random trial, and X is required number of success. So if we are given with this three quantity, then we can find out the probability at any given number of trial. So we can see that P of X equal to NCX P raised to X into 1 minus P, that is 1 minus P implies to Q, that is probability of failure. Here P implies probability of success, N implies number of independent trial, and X implies required number of successes. So 1 minus P raised to N minus X. Now binomial distribution in general it is having two parameter. One parameter is N and another parameter is P. Both symbol are we have discussed earlier in this topic. Now what is mean of the distribution? Mean is equal to mu equal to N into P. The standard deviation of binomial distribution can be given as standard deviation sigma equal to under root NP into 1 minus P. Again we can also write as under root NP cube. Okay, so in this slide we have learned about probability density function, parameter of binomial distribution, mean and standard deviation. Now we are having question that what is the real-time example of binomial distribution. So we are looking at it. So first of all, number of defecting bolts in sample consisting of n bolts. So in this type of problems we are given with probability of defective number of bolts. That means in given population there are some number of bolts, let's say 2% of bolts are defective. Now if we are asked to find out probability that out of sample of 10 bolts, if I want 4 bolts to be defective, then how to find out that probability? Here we can see that the probability of success, that means probability of defective bolt, is 0.02, N would be 4, and we need to find out P of X equal to 4. This distribution is binomial distribution. Another example of while we are rolling a die, we need to find out that what is the number of head in the experiment of rolling a die. That means number of head is having binomial distribution with parameter P is equal to 0.5. That means if we have assumed here is fair die, that means it is having similar chance of getting head or tail, and N implies total number of trials. Now number of graduates in a group of n people. So the number of graduates varied in different region. So it is also following binomial distribution. Number of correct answer out of n multiple choice question, it is also having binomial distribution. How? That means out of 4 options, 1 option is correct, or out of 5 options available, 1 option is correct. That means all the trials are having same probability and the number of trial is fixed, that is n. Now how do we identify that the distribution is binomial distribution? There are certain conditions. Mainly there are 4 conditions from which we can get to know that what is binomial, how to identify the binomial distribution. So let's get into that. Conditions for binomial distribution. First of all, the number of trial must have to be finite. The number of trial cannot be indefinite. That means there has to be fixed number of trial. We cannot say that the number of trial are not defined. First of any experience, we need to mention the number of trials. That means n is finite. Second parameter, it has to be finite. Now there are only two possible outcomes, either success or failure. We can say that it is having Bernoulli distribution because there is only two possible ways, either failure or success. It has to be what we can say that in digital world we can say that it is having distribution like uh, staggered manner. I mean, either you have one chance or another chance. There is nothing like third chance is available. The third condition, the trial has to be independent of each other. That means if I do experiment for the first time, then that experiment should not relate to the further coming experiment. If we simplify that, then when we are rolling a die, the chances of getting head or tail is independent of each other in each trial. So trial are independent of each other. Fourth one is probability of success has to be constant and it has to be same for all the trials. So four conditions are that. First is number of trials should be fixed. Another one is there is only two outcomes. That means Bernoulli distribution has to be follow Bernoulli. Third one is trial should be independent of each other, and fourth one is probability of success should be constant for each trial. Now we have learned basic concept of binomial distribution. Now onwards we'll get to learn the solved example of binomial distribution. So this is the randomly solved example of binomial distribution. Mary's final exam for psychology has 10 true false questions and multiple choice questions with choice for each answer. Assume Mary randomly guesses on every question. What's the probability that she gets 7 of the 10 true false questions correct? Here in part A, the questions are having only two possible options available. The question could either be true or it could be false. So out of true or false, we are having only one question is correct. So probability of success, that means probability of getting correct answer, P is equals to 1 by 2, which is equals to 0.5. So our first parameter has been fixed. Now what will be the second parameter? Our second parameter is n, that is number of trial. Number of trial is already given as finite and it is 10. So we are having distribution can be symbolically represented as x follow binomial distribution. P is equal to 0.5, n equal to 10. So the probability of getting 7 of the 10 answer is correct is equals to x equal to 7. Here we will get to use the probability density function, that is NCX p raised to x q raised to n minus x. Again I have told that q implies 1 minus p and x equal to 7. So what would be the answer? Simplifying, putting this value into this equation, that is 10c7 0.5 raised to 7 into 1 minus 0.5 raised to 10 minus 7. By simplifying this value, the answer would be the answer would be 0.1172. So 0.1172 is the correct answer for first question. That means probability that she get 7 of the 10 true false question correct is nothing but 0.1172. This answer we have obtained through binomial distribution. Now what second part tells us, let us know. Now what is the probability that she gets at least 5 of the 10 MCQ as correct? So in multiple choice question there are 4 options available: A, B, C, D. Out of 4 only one question is correct one. So probability of success is P is equals to 1 by 4, that is equals to 0.25. Sorry. Now this one is the first parameter. Another parameter is n, that is equals to 10, which is already fixed and it is given. So the distribution would be x implies binomial p equal to 0.25 and n equal to 10. By writing our answer, that is p of x greater than or equal to 5. Here we has to know that here it is mentioned that at least 5. Now let us take some small note. This when to use greater or equal, when to use less than or equal. If it is mentioned that here greater than, then it is okay. But if it is mentioned that at least, then we need to use greater than or equal. If at most is given in question, then we need to use less than or equal. If lesser is given, then we need to use less than, and if more than is given, then we need to use greater. So if at least is given, then we need to use greater than or equal. Now right, there is eraser, yeah, it is here. Sigma x equal to 5 to n and x p raised to x q raised to n minus x. Here we know that this one is the probability density function and this one is taken for cumulative distribution, as we need to find a probability for at least, that means p of x greater than or equal to 5. So that would implies that x equals to 5 to 10 and is 10x 0.25 raised to x 1 minus 0.25 raised to 10 minus x. So if we simplify this answer, then we will get the final answer as 0.0781. So the probability that she get at least 5 of 10 question is correct is nothing but 0.0781 that we had find out through binomial distribution. Now these are the steps what we are using with binomial distribution for solving the problem. But through greater f we can get step by step solution to this kind of problem and any other distribution. So let us just solve this example with greater f. So let us do the simulation with greater f. So in greater f there is home page, and in home page it is mentioned that the binomial, so user has to just click the binomial distribution, then you will get divert to this page. In this page user had to enter the data. So in our example, as we had seen that the trial has been fixed, it is 10, probability of success is 0.25 and the cutoff value it is 5. Now what is the probability that user want? He had to select from this. So the probability we want is greater than or equal to x. So if we click on the submit button, then this window will open and it will get redirected to step-by-step solution to the problem, and we will get our final answer as 0.0781. Please do like, share and subscribe our Bretter YouTube channel, and also you can download the Bretter app from Play Store and for Google, for App Store. We are also available in Instagram. Please do visit our Instagram page and like and get your updates, and also you may visit our website. Okay, thank you. Best of luck for your future enhancement.